All right, welcome back. We're on to chapter 5. So this chapter is going to start feeling a lot more like algebra, what you probably thought of algebra. So everything leading up to this point have been sort of foundation, things that we need to continue on throughout the rest of the course. So there is a jump up in difficulty in this chapter, but it's also kind of neat seeing all the things we've learned sort of come together into this chapter here. So if you do need to go back to previous chapters and sections to refresh on some of the topics, feel free to go ahead and take a break from this chapter and go back and make sure that your foundation is really good for the previous topics. So with that out of the way, let's go ahead and jump into it. So we're on to 5.1, which is expressions. So first of all, what is an expression? So some examples of expressions are maybe something like, I need my pen here. Something, let's go back, like 2 plus 7 minus 3, that's an expression. 3 plus x minus 6, and x squared minus 3x plus 9. So basically it's some numbers along with some operators, some addition, subtraction, multiplication, division. There's no equal sign. If there was an equal sign, it would be an equation. So an expression is sort of a part of an equation. So a term is each of these number sections. So 2 here is a term. This -3 is a term. X is a term. X squared is a term, and so on. All of these individual components of the expressions are terms. So a coefficient, what's a coefficient? So a coefficient is going to be the number in front of a variable. So we have an example right here. We have -3, that's a coefficient in front of x. So a coefficient in front of x squared would be 1, because there is no, it's just blank right there, so we know that the coefficient is 1. A constant is a number that does not have a variable attached to it. So like 2, that's a constant. This 9 is a constant, and so on. Because it doesn't matter what the value of x is, it will always be plus 9. Equivalent. Equivalent means the same or equal. So some expressions that are equivalent might be like x plus 7 and 7 plus x. These two expressions are equivalent. Another example would be 1 over t and 2 minus 1 over t. Right? These two are equivalent because this simplifies down. 2 minus 1 becomes 1 over t. And I just said simplify. When an expression is simplified, that means it's down to the least number of components that there can be, or the least number of terms it can be. So if we take this expression, for example, we can combine a lot of these terms, combine all 3 of these terms. 2 plus 7 would be 9, minus 3 is 6. So the simplified expression is just 6. So how about this one right here? We have 3 plus x minus 6. Well, we don't know what x is, so we don't know what we would add to 3. So we have to leave x as a variable. But we can do 3 minus 6. And 3 minus 6 would be -3. So simplified down, this could be written as x minus 3 or -3 plus x, whatever you prefer. They are equivalent. And this expression right here is already simplified because you can't combine x squared along with x. All right, so jumping into some of the problems. Are -x plus 6 and 6 minus x equivalent? All right, well, we know that addition is commutative, so we know we can change the order of this. So then this would become 6 plus -x. We know adding and negation is just subtraction, so that becomes 6 minus x. So that looks good to me. Are t plus 1 and t minus 1 equivalent? Well, let's say t is equal to 1. If t is equal to 1, then this would be 2, but this would be 0, so they are not equivalent. Okay, are 12 over x and 3x equivalent? All right, so, well, we know that 12x over 4 is the same thing as saying 12 times x over something like 4 times 1, right? Because 12 times x would be 12x, 4 times 1 would be 4, so then we get back to 12x minus 4. All right, then we can break these up and say this can be 12 over 4 times x over 1. And 12 divided by 4, we know is just 3. X divided by 1 is 1. So it's 3 times x, which would be 3x. So it looks like that is good. Okay, r squared and r, are those two equivalent? All right, so we can do the same thing. So r squared is the same thing as saying r times r over r times 1. Split them up and say r over r times r over 1 equals 1 times r, and that's just r. So, yep, those are equivalent also. Okay, Jeremy has 5 packs of gum, and Shannon has 6 packs of gum. Suppose each pack of gum has X pieces of gum. Write an expression for the number of pieces of gum Jeremy has. Okay, let's start with that. Write an expression for the number of pieces Jeremy has. Jeremy has 5 packs of gum, and each pack of gum has X pieces in it. So he has 5 packs of gum, and there's X pieces of them, so he has 5 times however many pieces. Let's call it X, 5 times X, number of pieces, or 5X. Okay, write an expression for the number of pieces of gum Shannon has. Well, Shannon has 6 packs of gum. Okay, write an expression that each, write 2 different expressions that each equal the total number of pieces of gum the two of them have together. Okay, anyways, so Shannon will have 6X pieces of gum, right? She has 6 packs of gum, and each pack has X number of pieces in it. Okay, write 2 different expressions that each equal the total number of pieces of gum the two of them have together. Okay, so 2 different expressions that equal the combination of these 2. So we know we can do 5x plus 6x. You know, that's one way we can write it. Another way is we can write it 6x plus 5x. That would be equivalent, right? Okay, and then we go on to B. Simplify the expression 5x plus 6x. So it wants to know how many pieces of gum do they have in total. So let's say that each pack of gum has 10 pieces in it. Then this would be 60, right? 6 times 10 is 60. This would be 50. And 60 plus 50 would be 110. So, yeah, if you have, I'm trying to think of a good way to explain this. If you have 3 baseballs, okay, 3 baseballs, and then you are given another baseball, or let's say 2 more baseballs. You're given 2 more baseballs. Okay. And how many baseballs do you have? Of course, you have 5 baseballs now. 5 baseballs. Just like this, if you have 6 pieces or 6 packs of gum, and then you add 5 packs of gum, now you have 11 packs of gum. And so if each pack has 10 pieces in it, then of course you have 110, just like you're supposed to. So you can just add up the coefficients of these variables when you add, and then you get the total there. All right, so Allison has 3 boxes of chocolate and 5 extra pieces of chocolate. Atlas has 4 boxes of chocolate and 8 extra pieces of chocolate. Suppose each box of chocolate has X pieces of chocolate. All right, write an expression for the total number of pieces Allison has. All right, so Allison has 3 boxes of chocolate, so she has 3, and each box of chocolate has X pieces in it, so 3X. Write an expression for the total number of pieces Atlas has. All right, Atlas has 4 boxes of chocolate and 8 extra pieces of chocolate. So Atlas has 4 boxes plus another 8. And then how many do they have together? That would be 3x plus 4x plus 8. Okay, and so simplify this expression. 3x plus 5 and 4x plus 8. Oh, I didn't see this part. Okay, 5 extra pieces of chocolate, so plus 5. So let's go ahead and undo this. So 3x plus 5 plus 5 plus 4x plus 8. Okay. So, and then they did the same thing, but parentheses around these. So we'll simplify this expression. So we don't really need these parentheses. They don't really do anything. So we know we can rearrange this. So we can bring the 3x and 4x and group those together. We know addition to associative, so we can regroup. So we can say 3x plus 4x plus 5 plus 8. 3x plus 4x is going to be 7x plus 5 plus 8 is going to be 13. And that is simplified. We can't simplify that anymore. Okay, so now we'll simplify this expression. Again, we can go ahead and regroup. So actually, you know what? First, let's go ahead and convert this to addition to make sure that we're not forgetting to bring negative signs along with us. Right, now everything is addition, so everything is associative. So now we can go ahead and regroup. So let's say 5r plus 4r minus 3r, because we brought the negative sign along with us. Okay. Plus negative 6 plus 1 plus 9. Okay, so we got the constant terms grouped together and we have our variable terms grouped together. Okay, so let's say 5 plus 4 is 9 minus 3 is going to be 6r plus, and here we have let's see, we can do 9 minus 6. We could rearrange this. 9 minus 6 is 3, plus 1 is 4. And there we go. Okay, so yeah, so problem 5.4. Let's expand this. So we remember our distributive property. So we'll go ahead and distribute this out. So this would be 7y plus 14. Okay, and it looks like it's simplified already. Simplify the expression 6r plus all of this. So let's go ahead and first we will distribute this too. So 6r plus 8. And make sure you remember this negative sign. The thing that's going to mess you up the most in algebra is likely going to be missing signs. So be really careful with making sure that you're putting all the negative signs where they need to be. So it would be 2 times negative 3r would be minus 6r. Okay, and so simplify the expression. Well, 6r minus 6r, that just cancels out. That's just a 0. And then we're left with 8. All right, make sure that that is correct. Yep, okay. Now simplify this. Once again, we'll go ahead and distribute this 5. So 5z minus, again, so 5 times negative 3 would be negative 15. Plus 3 times 7 would be 21. 3 times negative 2z would be negative 6z. All right, if we combine our z terms, looks like we have negative 1z. We can just say negative z. And negative 15 plus 21, the same thing as 21 minus 15 would be positive 6 plus 6. All right. Okay, Yao Ming is 7 feet 6 inches tall. Earl Boykins is 5 feet 5 inches tall. How much taller is Yao Ming than Earl Boykins? All right, let's see here. So if Yao Ming is 7 feet and 6 inches tall, and Earl Boykins is 5 feet 5 inches tall, right? We can do that. That makes sense, right? How much taller is that? So what's the difference between these two? What's the difference between the two? And remember, difference between this entire thing. So we can start off by distributing this negative sign. So now we have 7f plus 6i minus 5f minus 5i. Okay, 7f minus 5f would be 2f. 6i minus 5i would be 1i. I'll put the 1i there just because it's talking about 2 feet and 1 inch. Oh, this should be plus, right? 6i minus 5i is plus 1i. That looks weird here. This is a 1i. Okay, so 2 feet and 1 inch is the difference between these two. Okay. So we have 7x plus 6 minus 5x minus 5. Simplify this, same thing. We're going to distribute this negative sign. This will be, it'll end up being minus 5x minus 5. Okay, so we did do 7x minus 5x would be 2x. And 6 minus 5 would be 1. I did the same thing again. 6 minus 5 would be 1, plus 1. Okay, simplify this expression. Same thing. So 8a minus 3. Distribute the negative 2. Bring that negative along with you. Don't forget that. You can also change this to addition and make sure you realize that that 2 is a negative 2. So I'll do that for now. I'll say plus. It's going to be negative 6. And negative 2 times negative 5a is going to be positive 10a. Okay, so now what can we combine? We have a negative 6 and a negative 3. That would be negative 9. We have 8a plus 10a. That would be 18a. Okay, and that looks good. That's simplified. Also, there's 2 videos here. We can go check out this simplifying linear expressions and algebraic expressions number game. All right, so back to fractions. You thought we were done. So 10t over 6 plus 12t over 9. Well, first of all, we can simplify these fractions. So we have 10 over 6. That can be simplified down. If we divide both by 2, we can say 5 over 3t plus, we can simplify this down also. We can divide both by 3, it'd be 4t over 3. They still have the same denominator, so that's okay. Be careful though, because if you simplify fractions that already have the same denominator and then you make them not have the same denominator, you might accidentally be making the problem harder. In this case, we made it easier because now we both simplified the fractions and we got a similar denominator. So that worked out great. So this is going to be 9t over 3. And once again, we can simplify this down. This would become 9 times t over 3 times 1, which would be, 9 over 3 times, I could say t over 1, which would be 3t. Okay. And now this next one, we have negative 2x. Again, remember that negative. So let's see, we need a common denominator here. What's the lowest common denominator? Looks like 21, 7, 14. Those are not multiples of 3, so 21 will be it. So this one here, times 7 times 7. This would be negative 14x over 21 plus, it's going to be 3 times 3, 15x over 21. Well, so we have negative 14 plus 15. We could swap these orders if you wanted to do that. Do 15 minus 14. We're going to be left with 1 over 21. And that'll be positive. Positive 15 minus 14. So that'll be positive 1 over 21. Oh, 1x, that is. Don't forget our x, 1x, which we can write, as just x over 21. There we go. Okay, express a over 2 plus all that stuff as a single fraction. So let's go ahead and first get a common denominator. So let's do times 2 here. So then we have 2a over 4 plus all of this. So basically we just combine it in the numerator of the fraction, right? They have the same denominator now. So now we can say plus 6a minus 5. Now we can combine our terms. So 2a and then another 6a would be 8a. 8a minus 5 over 4. Okay, one thing to note here, we cannot simplify this. I know it's very tempting to say we have a multiple of 4 here and 4 in the denominator. So, that would be 4 over 1. But we cannot do that because we have another term here that is not a multiple of 4. So this could be broken up to say something like 8a over 4 minus 5 over 4. And now you're probably thinking like, well, I can simplify this, right? 8a over 4. Well, sure, this is going to be 2, and this will be 1. So then now I'm left with 2a minus 5 over 4. But now, if we want to combine them into a fraction, well, now we need a common denominator. So now we have to do, so if we had 2a over 1, it would be times 4, and then it goes right back to 8a over 4, and then 8a minus 5 over 4. So however you like to write this, you could actually simplify part of this down and have 2a minus 5 fourths if you prefer to have it not in a full fraction term like this. But be careful when you simplify things like this, that you got to remember that this denominator applies to both the 5 and the 8a. All right, and it says as a single fraction, so this would not be correct for this problem. It would be equivalent. These two are equivalent, but for this problem, that would not be correct. Okay, so express this as a single fraction. So they don't have a common denominator. So what would be a common denominator? So we have 6, 12, 18 sounds like a common denominator. So if 18 is, it means we have to do times 3 and times 3. So if we do, let's go ahead and write this out. So 3 times 2x plus 7 over 18 minus, and then we have to multiply this side by 2 to get 18 on the bottom. So let's do 2 times 9 minus 2x all over 18. Now, when you start doing stuff like this, that might start to look scary. This is a bigger problem than we're used to, with a lot more numbers and a lot more terms than we're used to. There's fractions involved, there's negative signs involved. But we should know everything that we need to know in order to solve this problem. So just take it one step at a time, do the things that you know how to do, and it turns into a problem that seems a lot more manageable. So first thing to do here, if you just look at the problem and think for a second, you can think maybe, well, I know how to distribute. I can see distribution here. Maybe I'll start there and see where that leads me. So let's go ahead and distribute this. So that's going to be 6x plus 21 over 18 minus, still distribute and say 18 minus, remember the minus sign, 2 times negative 2x would be negative 4x or minus 4x over 18. Okay, so now we're going to subtract this problem. So also note that this subtraction here applies to the entire fraction. This whole fraction is negated. So when we combine these into a single fraction, we need to remember that. So we do 6x plus 21 minus, and then this grouping of 18 minus 4x. Okay, and then on the bottom we still have our 18 denominator. So you could say, well, why didn't I say negative 18 here? Because wouldn't the negative sign apply to both the top and the bottom? And the answer is no. The negative sign applies to the top or the bottom. Remember that division is a negative times a positive is a negative. So if we said a negative divided by a negative, that would end up being a positive. That's not what we want. We want this to stay negative. So this negative sign has to apply to the top or the bottom. But since we want a common denominator, we don't want the bottom to be negative 18. We want it to be positive 18. So we applied the negative sign to the top. Hopefully that makes sense. But now we can distribute this negative sign. So that becomes 6x plus 21 minus 18 plus 4x over 18. Okay, now we can combine like terms. And so we have a 6x and a 4x, that's 10x. I like to put my variable terms first. That's pretty common to do. And now we have 21 minus 18, which is 3, so plus 3, all over 18. Now, can we simplify this? Well, 10 and 18, they do have common divisors. And 3 and 18, they also have common divisors, but they're not the same common divisor. So this is actually as simplified as we can make a single fraction. And that's it for that, that section. Hopefully that wasn't too bad. Go through and run through that section again if you need more practice. Otherwise, go on to your 5.1 exercises, and that'll give you a lot more practice too. There's a lot of exercises, and so get really good at simplifying these expressions before moving on to the next one. And next section is going to be solving linear equations, which you might have done before, but that really feels like some real algebra there. So I'll see you for that.